What specific problem does your proposed benchmarking method aim to solve regarding the reliability of large language models, LLMs?
The proposed benchmarking method aims to solve the problem of accurately assessing the reliability of large language models, LLMs, on tasks where they have previously been deemed to have reached saturation in performance, such as achieving 95% accuracy on older benchmarks like GSM-8K. Our findings indicate that the remaining errors in these benchmarks are not merely due to label noise, but represent genuine model failures. By creating platinum benchmarks that are meticulously curated to eliminate label errors, we can ensure that any incorrect answers from models indicate a true failure, rather than ambiguity in the questions. This new benchmarking approach allows us to rigorously quantify model reliability and identify the specific tasks and difficulty levels at which models can consistently perform accurately. Ultimately, this method addresses the critical need for reliable evaluations in safety-sensitive applications, where even minor errors can have significant consequences.
How does the proposed benchmarking method work? Illustrate it step by step, including the process of creating platinum benchmarks and how they differ from original benchmarks.
The proposed benchmarking method involves several key steps to create platinum benchmarks, which are designed to rigorously evaluate model reliability. First, the process begins with identifying and categorizing common types of errors in existing benchmarks, which often contain label errors or poorly defined questions. Next, these errors are corrected or removed to ensure that every incorrect answer from the model indicates a genuine failure rather than an issue with the benchmark itself. This results in a curated set of benchmarks that are unambiguous and clearly defined, allowing for accurate assessments of model performance. Finally, the reliability of frontier models is evaluated using these platinum benchmarks, which differ from original benchmarks by being cleaner and more reliable, thus providing a more accurate measure of a model's true capabilities.
Can you provide a simple yet illustrative example of how one of the platinum benchmarks can be used to evaluate the reliability of a frontier language model on a specific task?
One illustrative example of using a platinum benchmark to evaluate the reliability of a frontier language model is through the revised mathematics benchmarks, specifically the single OP benchmark, which consists of simple arithmetic problems. For instance, if the benchmark includes a straightforward question like, "What is 7 plus 3?" a reliable model should consistently answer 10 without error. By measuring the model's performance on this task, we can determine its reliability in handling basic addition problems. The platinum benchmark ensures that any incorrect answer reflects a genuine model failure rather than issues with the question itself, allowing for a clear assessment of the model's capabilities. This method highlights the model's reliability frontier, pinpointing the level of difficulty at which it can maintain near-perfect accuracy.
What are the theoretical and practical benefits of this new benchmarking method compared to existing benchmarks in terms of evaluating model reliability?
The new benchmarking method proposed in the paper offers significant theoretical and practical benefits over existing benchmarks for evaluating model reliability. Theoretically, it aims to create platinum benchmarks that are meticulously curated to eliminate label errors, ensuring that any incorrect answers from models are genuine failures rather than artifacts of poorly defined questions. Practically, this method allows for a more granular assessment of model reliability across a spectrum of task difficulties, enabling researchers to pinpoint the exact difficulty level at which models begin to falter. The findings indicate that current benchmarks often contain substantial noise, with many errors attributable to mislabeling, which the new method addresses by providing a clearer and more reliable evaluation framework. Ultimately, this approach not only enhances the accuracy of reliability assessments, but also facilitates the identification of specific failure patterns in models, leading to improved understanding and potential mitigation of these errors.
How did you validate the effectiveness of your proposed benchmarking method? What data sets and metrics did you use, and how did you ensure that your findings were robust?
We validated the effectiveness of our proposed benchmarking method by constructing a set of Platinum benchmarks, which involved identifying and correcting label errors in existing datasets. We specifically focused on mathematics benchmarks, revising 6 of them that ranged in difficulty from simple operations to high school-level problems. To ensure robustness, we manually inspected all model errors during the revision process, confirming that every reported failure on our Platinum benchmarks was genuine and not due to question ambiguity. Our findings were further supported by comparing the frequency of errors on the original noisy benchmarks to our cleaned versions, revealing significant differences in model performance. This rigorous approach allowed us to pinpoint the reliability frontier of frontier LLMs and identify patterns of failures across various tasks.
What limitations or challenges did you encounter with your proposed benchmarking method, and how might they affect the results?
One significant limitation encountered with our proposed benchmarking method is the inherent noise present in existing benchmarks, which can obscure the true reliability of models. For instance, we found that a substantial portion of errors in original benchmarks stemmed from mislabeling or poorly constructed questions, with about 75% of errors on the SVAMP benchmark attributed to such issues. This noise complicates the evaluation of model reliability, as it can lead to misinterpretations of a model's performance. Additionally, while our Platinum benchmarks aim to provide a clearer assessment, the challenge remains in ensuring that all benchmarks are consistently curated and free from ambiguity, as any remaining label errors could still skew results. Ultimately, these factors highlight the necessity for ongoing refinement of benchmarks to accurately gauge model reliability across various tasks.